Unfortunately, what we see is the short channel devices exhibit far in excess value, exhibit noise in excess value compared by long channel devices. So the channel length inside the MOSFET is going to decide the performance of MOSFET, right? So they say that short channel MOSFET in saturation exhibit noise far in excess. So short channel devices are going to have more amount of noise when compared to the long channel devices. So this is found by measurements. So at different frequencies, they measured what is the noise current, and they found that MOSFETs which are going to have very, very short channel, so those are going to have noise very, very larger when compared to the long channel theory of MOSFETs. And the gamma value, I told it is actually 1, but it is typically, it can go up to 2 to 3 for long channel MOSFETs. Okay, so that is the parameter how it varies for a long channel MOSFET, and for short channel it will decrease. For long channel, this gamma is going to be a device parameter which is going to increase more than 1. So it is going to be 2 to 3 for long channel MOSFETs, but for short channel MOSFET, the value of gamma is going to be, the maximum value is 1, and it will start decreasing from 1. We have seen it will go towards 2 by 3 in the saturation condition. 2 by 3 in the saturation condition. So because in short channel devices, you can see the electric field is going to be very, very large. So the device, there is no enough space for the device to dissipate the heat. So that is the reason why this noise power is also going to pick up in the short channel devices. So in short channel devices, the noise, the power handling capability becomes very, very limited because the device length is fixed, right? So that is where we have to concentrate more on two things. One is how to reduce the heat which is present inside the device, which is generated by a large electric field. And if the heat is there, temperature will increase. If temperature is going to increase, the noise will increase. So we have to ensure that this heat is not going beyond the control, or this heat is not increasing the temperature of the device. So operate the device at a minimum VDS voltage. So the only option what you have in short channel devices is you are going to use devices which are going to operate in a very, very small VDS. So VDS is a drain to source voltage, right? So if you operate in a very, very small VDS, to some extent you can minimize this drain current noise in MOSFET. So PMOS devices do not exhibit that much noise until high fields are reached, so that they may be used when other characteristics allow it. So generally, when you consider NMOS and PMOS devices, they don't have this much amount of noise until the fields are very high. So if you have an option to go for choosing a device, you can definitely go for a PMOS device instead of having an NMOS device, which is going to have a very, very large amount of drain current noise in your applications. So this drain current noise is a very, very important parameter in MOSFET, which is going to be following the same mathematical model as a thermal noise, and this is going to dictate the performance of the complete MOSFET.